Hi, welcome to this webinar with Comap and with me, Sophie Keloganian. Today I suggest to talk about the balancing and about the static balancing valve, so the NexusValve Fluctus. The overview of this presentation, first I'm going back to the issue, so I'm going to present a non-balanced network and the result regarding the flow and the temperature. After that, I'm going to talk just a little bit about the objective of the balancing, and I will move on the NexusValve Fluctus. I'm going to describe the valve and to give you the benefits of the valve. And we are going to end this presentation with an application. So let's start with why balancing a network is required. The example, it's a residential building, it's an 8-story building. There is a collective boiler which is located in the basement, and we are going to focus on the heating network and on one specific riser. So you can see now the result when the network is not balanced. That means at the top floor of the building, so the network number 8, so the floor number 8, we have a lower flow than expected. The expected flow is 330 liters per hour per branch, so here it's lower. That means the temperature in the apartment is low, so 16 degrees, and the tenant here is getting cold. And at the same time, at the floor number 4, for example, the flow is nearly than the flow expected, so the temperature is correct, 20 degrees in the apartment, and the tenant is comfortable. And at the same time, at the first floor, there is a high flow, a higher flow than expected, 31% than expected, and the temperature is getting higher. You can see here that from the top and the bottom of the building, there are 5 degrees of difference. That's the consequence when the network is not balanced. So what happens in these conditions? The tenant at the top of the building is complaining, and the solution many times is to boost the pump. But it's not the right solution. If we boost the pump, of course, we are going to increase the flow and to increase the heat provided, the provided heat to the apartment. But when the temperature is increasing about 1 degree, that means an overconsumption, an energy overconsumption equal to 6 to 10%. So regarding the energy consumption and regarding the cost, it's not the right solution, but there are also other consequences. So here you have the heat distribution when we boost the pump. So at the top of the building, the flow is correct, 330 liters per hour. So the temperature is nice, but the flow is getting higher when we go to the lower floors. At the first floor, the overflow is about 81%, so it's really high, and the temperature is also getting higher. So it's less comfortable for the people, and there is a global overconsumption equal to 41%. It's for the riser, for the whole riser. So an extra cost. Also, if there is an overconsumption and if we have only a boiler in order to provide the heat, that means a higher carbon footprint. And the other consequences are, first, the return temperature, which is going to be too high if we have a condensation boiler. If the return temperature is too high, that means that the boiler is not going to condensate anymore and the yield is decreasing. So it costs a lot. At the same time, if the flow is higher than expected, that means the water velocity is also too high. And if the water velocity is too high, that means that leads to noise, to erosion, and if there is erosion, that means a premature aging of the equipment. So it costs also regarding the equipment. So to sum up this information, it's necessary to balance the network, because with no balancing, that means for the tenant, it's not comfortable because of the temperature, too low or too high. It's noisy because of the water velocity. It costs a lot. There is an extra cost. For the maintenance company, that means a higher frequency of intervention in order to boost the pump, and also in order to repair if there is a leakage. And for the owner, for example, the social landlord, that means to manage the complaints, and there is also an extra cost. So it's necessary to balance the network. And now we are going to talk about static balancing. First, the objective of the balancing. The balancing, the purpose is to provide a nice temperature everywhere in the building. So to provide a nice temperature in all the apartments. When there is no balancing valves, we have just said that the temperature is too low at the top of the building and too high at the bottom of the building. So we want to have the same nice temperature everywhere in the building. In order to achieve these results, it's necessary to adjust the flow into all the emitters. So that means adjusting the flow everywhere in the network. And that means also, at the same time, adjusting the pressure losses through the network. So there are two parameters for the balancing valves. First, the flow, and second, the pressure drop across the valve. Sorry. When we talk about static balancing, it's the same than speaking about manual balancing. That means the same thing. And the static balancing means adjusting the nominal flow everywhere in the network, and specifically in the emitters. The nominal flow, it's the calculated flow in order to heat the room when the outside temperature is the lowest in the year. For example, in Briançon, in France, in January, the outside temperature may be minus 19 degrees, and so the nominal flow is calculated in order to heat the room when the temperature is as low as minus 19 degrees outside. So that's the maximum flow we can have through the emitter. The static balancing must be done for all new building, all new ring network, and it also must be done in case of big renovation. For example, if there is an exterior renovation, insulation of facades, it's necessary to do the static balancing because the heat requirement will be lower than it was before. The location of the static balancing valves now. So we are going to install a balancing valve everywhere the network is, the water flow is divided into two different flows. That means on the risers, here and here. That means on the branches, here, here, here. You can see all the valves on the branches. And on the emitter, so that the red dot you can see everywhere on the radiators. For example, if we are talking about radiators, that means the lock shield or the thermostatic valves. There is also, it's also necessary to install a balancing valve on the most resistive circuit. You can see here in the riser, there is no, the flow is not divided into two different flows, but that's the most resistive circuit. So I'm going to install a balancing valve. That's the same for the branches. We are going to install balancing valves on the most resistive circuits. Why? It's not to adjust the flow because the valve is going to be fully open, but it's in order to be able to do diagnostic when the network is operating. If there is a problem on the network, if we don't have balancing valve, we can't measure the flow. And if we can't measure the flow, it's impossible to make diagnostic. So as it's necessary to add stop valves, so it's better to have a valve with an added value, so a stop valve plus a setting valve, so a balancing valve. So it's better to install a balancing valve instead of installing only a stop valve on the most resistive circuits. This valve here is close to the pump. It's the compensation valve in order to adjust the whole flow for the whole network. Let's talk now about the NexusValve Fluctus. So first, it's a needle valve. You can see the needle here in order to adjust the flow. It's a static balancing valve with a fixed orifice. Fixed orifice, double regulating valve. The fixed orifice is for the flow measurement, and the fixed orifice is due to the venturi you can see here. So we are going to measure the flow through these two pressure ports, and the venturi gives a fixed orifice. The valve has 99 positions in order to adjust the flow. The technology of the valve now. You can see here a handle and the ball. So first there is a stop valve. It's a ball valve. And inside there is a needle in order to adjust the flow with the position. You can see the position on the top of the handle. And you can see here that it's necessary to have an hexagonal key, so an Allen key, in order to adjust the flow. So it's very easy. So the valve parameters are written on the top of the handle. Here you can see position 52. So the ball valve, the needle to adjust the flow, and here there is the venturi, and there are also the pressure ports in order to measure the flow. So that's because of the venturi that we called this valve a fixed orifice valve. Another view here, you can see the cut of the valve with the needle inside and the stop valve here with the ball. So it's a needle valve. What does that mean? That means we have a better resistance to fouling, erosion, and cavitation. To explain the cavitation in 2 words, it's when there is a pressure drop just before the valve, and because of this pressure drop, the fluid vaporizes. Just after the valve, the fluid is going to condensate, and this phenomenon generates a shock wave which is 7 times higher than that the steel can withstand. So it causes a lot of damages to the pumps and to the valves. So it's really important to pay attention to the cavitation. If we compare the needle valve and the seed valve, we can explain that the better resistance for the needle valve. Indeed, for the seed valve, you can see a seed valve here. The water is going through from the left side, and you can see that the valve here is in opposition to the flow. So that means it's easier in that case to generate fouling and erosion of the valve, and also cavitation. As we have a needle here, we have a better resistance to this phenomenon. So there are less risk of leakage, and there is no premature aging of the valve. So it's more robust. We said that it's a combination between a stop valve, a ball valve, and a balancing valve with the needle. So here we have two, a stop valve and a setting valve, which are dissociated. And there is a handle to operate the stop valve, so it's easier. We can see immediately if the valve is closed or open. If it's open, the handle is parallel to the pipe, and if it's closed, the handle is perpendicular to the pipe. So it's very easy. We can see immediately the position of the valve. And there is also another advantage is here, another benefit. It's there is no need of setting memory. We can't lose the settings. The flow measurement now. So in order to measure the flow, it's necessary to plug the balancing device to the pressure ports. And in the balancing device, the only input is the name of the valve. For example, Fluctus valve DN15S. And with this only information, it's possible to read the flow without to directly read the flow. As there is a fixed orifice, that means for one delta P measurement corresponds one flow. So that means for the commissioning, for example, it's going to take 20 seconds because we can directly read the flow on the device when we are doing the setting. So it's very easy to it's very easy and it's very fast to adjust the flow. The other benefit, of course, as we have a flow measurement, it's possible to do diagnostic. The setting, as I've just said, an hexagonal key is needed, and there is 99 positions, so we can be very accurate to adjust the flow. And as I've just said before, it's a direct reading. We can turn the key and read the flow and stop when the flow is okay. The measurement accuracy, so thanks to the Venturi, the accuracy is about 3% and is constant. So that means if the valve is nearly closed or is fully open, we have the same accuracy, and it's very low. For most of the valves in the market, the accuracy is higher than 5%. So it's really, it's important. It's an important feature of the valve. It's thanks to the Venturi. No straight lines are required for the valve installation. So except for the pump, so we have to provide 5DN after or before the pump in order to install the valve close to the pump. But for the other situations, there is no straight lines of pipes required. So the valve may be installed close to the elbows, to the everywhere we want. There is no need to think about where we are going to install the valve in order to stabilize the flow. So it's a peace of mind solution because we can install it everywhere in the network. The portfolio now, it's also interesting because we are going to select the valve with the same DN as the pipe. In static balancing, usually we select the valve, if we want to make it easy, we select the valve with 1 DN below the DN of the pipe. It's in order to have enough authority about the valve, and it's in order to have a position 75% open. So it's what we usually do. In that case, we can select the valve with the same DN at the pipe because we have 3 ranges of flow: the low flow, the standard flow, and the high flow. So it's very easy for the installers. It doesn't have to adapt the network in order to install the valves. Let's talk now about the hot tap water loop. So the valve is certified for the drinkable water. So it can be used for the hot water loop, hot tap water loop. But pay attention to your country regulation. For example, in France, the water velocity has to be 2 meters per second minimum. The water temperature has to be 50 degrees for the return temperature, so minimum also. And the internal pipe diameter has to be 15 millimeters minimum. And there is something about the valve. The position of the valve has to be in order to allow a particle with a diameter of 1 millimeter to go through the valve. So pay attention to that. There are many things to be in line with, but pay attention to the valve. There is also a minimum cross section to adjust in order to use the valve for the hot tap water loop. Another benefit for this valve, so it's certified, but it's also, as we said, a needle valve, so it's resistant to fouling. That's interesting in the case of the hot tap water loop. An application now. So I've just give you all the benefits of the valve. We are going to see now an application. So it's still my residential building. So in order to install balancing valves, we have to do some calculations. So for every valve, it's necessary to know the flow and to calculate the pressure drop across the valve. You can see here for the 8 valves, so 1 valve per branch, there is a flow, so 330 liters per hour per branch. And you can see here the pressure drop across the valves. That's the calculation. From this calculation, we can select the valve. So in that case, it's a DN15 for the pipe. So we are going to take DN15 for the valves. And we are going to adapt the flow, so to choose the right range of flows in order to have the right position for the valves. The purpose of the calculations is to define the position of the valve. Don't forget that for the calculations, for the valve selection, Comap can help. Don't forget the Comap support in order to help you with your balancing projects. So the result here, you can see that the valves are about 75% opened. That's what we want in order to stabilize the flow and to have enough authority for the valve. The result is that we have a nice temperature everywhere in the building, the right water flow. Of course, it's accurate, 3% accuracy. And for the lifetime of the network, it's possible to do diagnostic. Something is missing here. It's the balancing valve at the bottom of the riser, but in that case, we are going to think about dynamic balancing, and it's another presentation. So to sum up now what we have just said and to give you all the benefits, to sum up the benefits of the Fluctus valve, we said it's a needle valve, so it's resistant to fouling. There is no risk of leakage, so no premature aging of the valve. The valve is certified for drinkable water, so it may be used for the hot tap water loop. There is a fixed orifice, so the venturi for the flow measurement, and we just have to use an Allen key in order to adjust the flow. So the benefit is that it takes 20 seconds for the commissioning, and it's a direct reading of the flow, so it's very easy to adjust. 3% accuracy, so there is no mistakes in adjusting the flow. We are sure it's going to be the right flow. No straight lines are required in order to stabilize the flow, so it's a peace of mind. It's peace of mind for the installation. There is 3 ranges of flow per DN. That means for the valve selection, we take the valve with the same DN as the pipe. There are 2 pressure ports, so it's useful to do diagnostic. There is a handle for the stop valve, so we can see immediately if the valve is open or closed. And it's a combination with the stop valve and a balancing valve, and there is no need of setting memory. Thank you for attending this webinar. So you can join us on CoExpert, you can join us on the social media. I wish you a very good day, and I say bye-bye. Thank you.